Okay, so lesson 2.09, isotopes, is also on the 2.10 quiz. All right, so we are going to talk about the atomic mass unit and isotopes, what these isotopes are. And you're going to learn how to kind of like document isotopes and be able to tell them apart from each other, things like that. So on the slide here, I pulled this right out of your lesson. And your lesson starts by talking about the isotopes of neon. All right, so we've got some information on here. And one thing I want to add, and I'll count these out with you, just because we just talked about ions, and ions, the big difference was electrons. So I'm going to real quick count, because I don't have this on here, but you can see in the picture that the electrons are there. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons in this one. My pen is not working out very well. That is a 10 though. Then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. And on the last one, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Just so we can confirm that these are not ions, right? All of these have 10 electrons and 10 protons. So they are overall neutral. All right. So isotopes doesn't have anything to do with what's going on with the electrons. But what else do you see changing on here? Hopefully you spotted this. Or maybe this. All right. So, big thing that is going on with an isotope is you have a different number of neutrons. All right, which in turn changes the mass. All right, so So an isotope is going to be something that has a different number of neutrons. All right, so that's your just basic definition of an isotope. Now, it's important to make note what might change in addition to the fact that the neutrons are changing. All right, because if you recall from the 2.08 video, we did a quick review on the beginning slide. If you remember, protons are always equal to atomic number. All right, so does changing the neutrons affect that at all? I hope you're saying no. That's good. All right, there's also the atomic mass. All right, we've talked about that before. Protons plus neutrons equals your atomic mass. Does changing the number of neutrons you have an effect on atomic mass? You should hopefully be saying, yes, Mrs. Pulling, it does. All right, so while it's not necessarily in the definition, because an isotope is just a version of an element that has a different number of neutrons, remember that this is going to affect something. This will affect your atomic mass. All right, so because neutrons have isotopes have different number of neutrons, isotopes will also have a different atomic masses. So, just a common example here, all right, carbon-14. You might have heard of it before. It's radioactive and it's used in carbon dating. All right, so carbon-14 is a carbon that has 6 protons and 8 neutrons. Carbon-13 has 6 protons and 7 neutrons, and carbon-12 is 6 protons and 6 neutrons. So when I write these names out, what's the number on the end there? Hopefully you might be noticing that it's the protons and neutrons added together. All right, so when we name an isotope, all right, if I just list carbon, then I'm just referring to the most common isotope. All right, but if I get specific and I tell you the number, then that gives me some information to work with. I can try to figure out how many neutrons there are. All right, so when you're writing an isotope, all right, to write an isotope, you're going to write the element name and then a dash, and then the atomic mass number. All right, so that's where that whole carbon-14, carbon-12. All right, so if you ever see that dash following in a number when you have a name, that's letting you know what your mass is. All right, that can come in handy in case you have a question where it's like, hey, how many neutrons are in carbon-14? All right, so just know that if you see a number written after the word, that's giving you the mass of that specific isotope. All right, so now if you think about it, pause the video, open up a periodic table. All right, if your periodic table is precise at all, it's going to have the mass of carbon as like 12.011. All right, now I'm going to explain in a second where those decimals come from, but before, when we were doing calculations about figuring out neutrons from the atomic mass, we would always round that number to the nearest whole number. All right, that rounded value, that is the most common isotope. All right, so if you round 12.011, what's the most common isotope of carbon? All right, so 12.011 rounds to 12. All right, so carbon-12 is your most common isotope. Carbon-12. All right, so if you ever see somebody not write carbon-12, just write carbon, then they're just talking about that most common isotope, the rounded mass value on the periodic table. So to explain those decimals on the periodic table, what those values do is they are acknowledging the presence of isotopes. Right? These are all naturally occurring things. There's just most carbon atoms, if you were to sit there and like analyze the carbon that's in pencil lead, most of the atoms that are in there are going to be carbon-12s. Right? Because you can't have partial neutrons or partial protons. But that mass number on the periodic table, what it does is it averages the proportion of carbon-12s and carbon-14s and carbon-13s to get that value on the periodic table. So it's a little bit bigger than 12 because, you know, if you have a sample of carbon, a certain number of them are probably going to be carbon-13s, and a few of them are going to be carbon-14s. All right, so that decimal value is just the average of all the different isotopes. All right, but most of them, you know, like 99% of the carbon atoms are going to be carbon-12s. It's just there's some that are going to be 13s and 14s, which makes that overall average mass a little bit bigger. All right, you don't need to know how to calculate that. I just want to make sure you understand that there is no such thing as a partial neutron. It's just that that's an average of the different, that's including the isotopes into the overall average mass calculation. Another thing I want you to be familiar with is this term atomic mass unit. All right, so that number on the periodic table, that mass number, is technically measured in atomic mass units, or AMUs. All right, and specifically, those are, you know, way back in the day, people who determined these numbers did it based off of being 1/12 of the mass of a carbon-12. All right, so protons and neutrons are equal to each other in weight, so we know there's 12 of them total, so a single atomic mass unit is just how big one of those is. Just something that you want to know. So some practice with isotopes. All right, for some of these you might need to grab a quick periodic table, especially if you don't have the atomic number or something like that. But just note that for all of these, all right, there's going to be a specific mass that you are using. All right, so if it's given to you, all right, so like for example, for the very first one, we're doing carbon 13. So instead of using the mass number off the periodic table, I'm going to use that 13 because we're dealing with that isotope. Now, my atomic number off the periodic table, that never changes. That atomic number is carbon's atomic number, and there is nothing that can change that. If the atomic number changes, you are no longer carbon. So my atomic number is going to be 6. That does not look like a 6. There we go. All right, my symbol is carbon, so C. And then I know atomic number and protons are equal to each other. All right. There's nothing on here about this being an ion. All right, isotopes are still neutral atoms. So my electrons and protons have to be equal to each other so that I don't end up with a charge. I don't want an ion in this case. And then my neutrons have to be what I would add to 6 to get to 13, so that's going to be 7. All right. So just to do one more quick one, trying to think. So let's see, nickel, just so I know when I write out this name, I'm going to write nickel 60. Actually, I don't know the atomic number of nickel. I need to look that up really quick. Hunting down a periodic table. Nickel is atomic number 28. All right, that should be 28, which means my protons are 28. I have no indication that this is an ion, so my electrons are going to be the same too because we're neutral. And then my neutrons are going to be 60 minus 28, which is going to be 32. All right. Let's see. I'm going to do one more. And then after this, and at this point, you might even want to pause, see if you can figure out how to do number 3 before I do it. But for this one, I'm given my protons, which means I can figure out my atomic number. I don't know if that mass number is going to be the most common isotope or if it's going to be a different one. But I know for sure my atomic number is going to match something. So I'm going to look for atomic number 78. And that is platinum. And this is going to be platinum 195. Symbol for platinum is PT. Actually, just to confirm, platinum's mass normally is 195, so that happened to be the most common one, but just be careful, that won't always necessarily be the case. My electrons are going to be 78, and my neutrons are going to be 195 minus 78, which is going to be 117? 117. Okay. Again, if this isn't making sense, in class we're going to practice with some of this number stuff. Make sure that you have this down solid, but continue practicing on with some of these and bring any questions you have to class.